This lesson is about electromagnetic radiation. This in front of you is called the electromagnetic spectrum. And what we can see here is that waves come in many different wavelengths, meaning one wave from a peak to a trough, so from a top point to a bottom point, would be different sizes depending on what kind of wave it is. So if you look at the waves, you can see some that we're kind of familiar with already. For example, a radio wave. So right now you have radio waves going through your body. For example, a wave for radio, like for Hot 97, which is 97.1. 97.1 is a certain frequency. Z100, 100.3 is a certain frequency. Because Z100, 100.3 has a higher frequency, it has a shorter wavelength. Either way, the waves that are going through you from radios are about the size of a football field. So they're very big waves, which means they have very low energy. If you look over to the right side and you look at X-rays, those are very small waves, which means they have high energy and they could be more dangerous to you. If you take a look at visible light, you can see that's a very small part of the spectrum is the light that we can actually see. And if you look to the left, you can see that infrared is just longer waves, so just lower energy than visible light. And you can see to the right that ultraviolet is just a shorter wavelength, so just a little bit more energy than a visible light spectrum. So ultraviolet is like the UV light that comes from the sun. We have a bunch of different features here. We have peaks and troughs, so if you could please label those on your diagrams. Okay, we also have some definitions here, and we're going to look at the wavelengths and some other features of these waves. So first of all, this first wave has a shorter wavelength because there's less distance between the peaks and the troughs, whereas the one on the right has a longer wavelength. There's more distance between each peak and trough. Frequency, we have a higher frequency on the left. You can see that there's a lot of waves in a short period of time. If you look at the same period of time, you would see that there's less waves in that same period of time. For amplitude, that just means how high the waves are. So a lower amplitude means there's less height. And then on the right, our higher amplitude means there's more height. This is how we refer to the intensity of waves. So for example, a sound wave with a high amplitude is going to be a louder wave that kind of shakes you, a more intense wave. Okay, and then we have two other kinds of waves we need to differentiate between. We have our longitudinal wave, which is a side-to-side movement, which we'll look at in class. And we have a transverse wave, which is an up and down movement we'll also take a look at in class. We have the electromagnetic spectrum here. This is actually the electromagnetic spectrum that you'll find in the reference table for earth science. So please make sure that you have all your notes done on what we've done so far, and we'll take a look at the electromagnetic spectrum in class. Have a nice night.